Cracking the code, your ultimate SQL debugging playbook. So you're wrestling with SQL. We've all been there, staring at an error message that feels like it's written in another language, or a query that returns, well, not what you expected. It can be frustrating, easily one of the more challenging parts of working with data. But here's the thing. Debugging SQL isn't some dark art. It's a methodical process, a skill you can totally level up with the right approach and a few solid techniques under your belt. Getting good at this means less time pulling your hair out and more time getting valuable insights from your data or building robust applications. Welcome to our guide on mastering SQL debugging. Today we'll walk you through some essential techniques to help you identify and resolve issues efficiently. Think of this as your toolkit for dissecting those tricky SQL problems. We're going to move beyond just staring at the screen hoping for a miracle and dive into practical, actionable steps you can take. Whether you're relatively new to SQL or you've been writing queries for a while but still find debugging a bit of a pain point, there's something in here for you. We'll cover everything from the very first step, actually understanding what those error messages are trying to tell you, to breaking down complex queries into manageable pieces, and even peeking under the hood with execution plans. We'll also touch on data integrity, the power of dedicated debugging tools, and the crucial, often overlooked step of testing with sample data. By the end of this, you'll have a much clearer roadmap for tackling SQL bugs head-on. Listen to your errors decoding SQL messages. All right, first up, and this might sound obvious, but it's foundational. Read your error messages carefully. I mean, really read them. It's so easy to just glance at that wall of red text, feel a wave of panic, and immediately jump to Google. But honestly, the database is often trying to give you some pretty specific clues about what went wrong. These messages aren't just there to annoy you, they're your first line of defense in the debugging process. They can point to syntax errors like a misspelled keyword or a missing comma, tell you if you're referencing a table or column that doesn't exist, or even indicate issues with data types or constraints being violated. Pay attention to line numbers if provided and any keywords that stand out. It's about training yourself to see these messages not as roadblocks but as signposts. For instance, an error like Aura 00942. Table or view does not exist in Oracle, or unknown column underscore name in where clause in MySQL gives you a very direct starting point. Is the table name spelled correctly? Are you connected to the right database schema? Did you mistype a column name? Sometimes the error message might seem a bit cryptic, especially with more complex issues, but even then there's usually a nugget of information you can extract. Learning the common error patterns for your specific SQL dialect, whether it's PostgreSQL, SQL, Server, MySQL, or something else, will make this process much smoother over time. Divide and conquer breaking down complex queries next. Let's talk about those monster queries, the ones that span multiple lines, involve several joins, subqueries, and complex conditions. When these go wrong, trying to debug the whole thing at once can be incredibly overwhelming. This is where the divide and conquer strategy becomes your best friend. The core idea is simple. Break down that complex query into smaller, more manageable logical units and then test each part individually. This helps you isolate exactly where the error is occurring or where the logic is deviating from your expectations. It's like troubleshooting a complex machine. You check each component rather than trying to fix the whole thing blind. So how do you actually do this? One common technique is to start commenting out sections of your query. For example, if you have a clause with multiple conditions, comment out all but one and see if it runs. Then add them back one by one. If you have subqueries, try running just the subquery on its own to ensure it's returning the data you expect. Common table expressions, CTEs, are also fantastic for this, as they allow you to define and test named result sets incrementally. You can, from an intermediate CTE, to verify its output before it's used in a subsequent part of the query. This iterative approach makes it much easier to pinpoint the exact line or clause that's causing the trouble. Under the hood, using explain and query execution plans. Sometimes your query runs without errors, but it's incredibly slow or it returns unexpected results due to how the database thinks it should get the data. This is where understanding query execution plans comes in. Most database systems provide a command, often or something similar, that shows you the step-by-step plan the database optimizer has chosen to execute your query. Think of it as the database showing you its internal roadmap, how it's going to access tables, what join methods it will use, and in what order operations will occur. This is an incredibly powerful tool, not just for performance tuning, but also for debugging logical errors that might stem from an inefficient plan. When you look at an execution plan, you're looking for inefficiencies. Are you seeing full table scans on large tables where you expect an index to be used? Are there costly join operations like nested loops where a hash join or merge join might be more appropriate? The plan will often show estimated row counts versus actual row counts at different stages, which can highlight where the optimizer's assumptions might be off, leading to a suboptimal plan. Understanding these plans takes a bit of practice, as the output can be dense, but it provides invaluable insights into how your SQL is actually being processed by the database engine, allowing you to make informed decisions about query rewriting or indexing. Chapter 4. The need for speed checking indexes and performance. Building on the idea of execution plans, let's specifically talk about indexes and their impact on performance, which can often be a source of perceived bugs when queries take forever to run or time out. Indexes are special lookup tables that the database search engine can use to speed up data retrieval. Properly designed indexes can dramatically improve query performance, especially for queries with clauses on large tables or for operations. If your query is unexpectedly slow, one of the first things to check, often via the execution plan, is whether appropriate indexes are being utilized. A missing index on a frequently queried column can be a major bottleneck. However, it's not just about adding indexes everywhere. While indexes speed up read operations, statements, they can slow down write operations, because the indexes themselves also need to be updated. So there's a balance to strike. You need to identify the critical columns that are frequently used in search conditions or joins and consider indexing them. Also, the of index matters, and sometimes a multi-column index is more effective than several single-column indexes. Regularly reviewing index usage and dropping unused or redundant indexes is also good practice for maintaining overall database performance and simplifying your debugging when performance issues arise. Chapter 5. It's not always the query verifying data integrity. This is a crucial one. Sometimes the problem isn't with your SQL query logic at all, but with the data itself. You can write the most perfect, optimized query, but if the underlying data is inconsistent, incomplete, or just plain wrong, your results will be skewed, or you might even get errors. Data integrity issues can be subtle and tricky to find. For example, you might have unexpected values in columns that are critical for a calculation or a join. Or perhaps there are orphaned records in a child table that reference non-existent parent records, leading to failed joins or incorrect counts. Data type mismatches, though often caught by the database, can also lead to implicit conversions that affect results. So part of your debugging toolkit needs to include methods for inspecting and validating your data. Simple queries or using on certain columns can help you identify anomalies or unexpected distributions. Check for values in key columns using. If your database enforces foreign key constraints, that helps, but sometimes these aren't rigorously applied or data gets loaded through bypass mechanisms. Understanding the expected state and relationships within your data is paramount. Before you spend hours tweaking a query, take a moment to sanity check the data it's operating on. You might find the culprit there. Chapter 6. The right tools for the job using logging and debugging utilities. While carefully reading error messages and breaking down queries are fundamental, sometimes you need more firepower. This is where dedicated logging and debugging tools come into play. Most modern database management systems and IDEs offer built-in utilities that can provide much deeper insights into query execution. For instance, SQL Server has SQL Server Profiler and extended events. MySQL Workbench has its own set of diagnostic tools, and pgAdmin for PostgreSQL offers similar functionalities. These tools can allow you to trace the exact SQL statements being executed, even those generated by applications, see how long each statement takes, and sometimes even step through procedural SQL code, like stored procedures or functions. Beyond database-specific tools, don't underestimate the power of application-level logging if your SQL is being generated or called from an application, like a Python script, a Java application, or a web framework. Good logging practices within your application can capture the exact queries being sent to the database, along with any parameters. This is invaluable when the query that's failing isn't one you're writing by hand, but one that's dynamically constructed. Having access to these logs, or being able to use a debugger in your application code to inspect the query string before it's executed, can save you a ton of guesswork. These tools give you a clearer window into what's actually happening. Chapter 7. Safety First. Testing with sample data. Finally, and this is a big one, especially when you're dealing with complex queries or critically any or statements, test with sample data before running anything against your production database. It sounds like common sense, but it's a step that's surprisingly easy to skip when you're under pressure. Creating a small, representative subset of your data, or even manufacturing specific test cases in a development or staging environment, is an incredibly important safety net. This allows you to iterate quickly and verify that your query behaves exactly as you intend without risking the integrity of your live, critical data. Working with a smaller dataset makes it much easier to manually verify the results. If your query is supposed to update 10 rows, you can easily check those 10 rows in your sample set. If it's supposed to return a specific calculation, you can do that calculation by hand on the small data to confirm. This approach not only helps you catch logical errors in your query, but also allows you to see the impact of your changes in a controlled environment. It's much less stressful to find out your statement was a bit too aggressive on a test table than on your main customer database. So make friends with development environments and sample datasets. They are key to confident SQL debugging and development. Outro, you've got this wrapping up your SQL debugging journey. So there you have it, a rundown of some top techniques to really get a handle on SQL debugging. We've covered the importance of carefully reading those error messages, the power of breaking down complex queries using execution plans, like to see what the database is actually doing, and why checking your indexes is key for performance. We also touched on verifying your data integrity, because sometimes it's the data, not the query. Leveraging dedicated logging and debugging tools, and the absolute necessity of testing with sample data before hitting that production environment. And there you have it. By following these techniques, you will be well on your way to becoming a SQL debugging pro. Remember, debugging is a skill, and like any skill, it gets better with practice. Don't get discouraged by errors, see them as puzzles to solve. Each bug you squash makes you a more effective and confident SQL developer. Hopefully, these strategies give you a solid framework to approach those challenges with a bit more clarity and a lot less frustration. If you found this guide helpful and you want to see more content like this, diving into tech, data and development, definitely do all the YouTube things. Don't forget to like, subscribe and hit the bell icon for more tech tips and tutorials. Let me know in the comments if you have any other go-to SQL debugging tricks, or if there are other topics you'd like us to cover. Thanks for watching, and I'll catch you in the next one.